Problem 8 involves us, actually, here we go. Okay. It involves something that's kind of unique. And I actually like it because it brings up a real important topic with a lot of these trig functions. Something that becomes abundantly clear to do with most of these. And so number 8 is going to have this. Number 8 has it that if we're dealing with, we have secant, and this time we're raised to the power of 4 minus tangent to the power of 4, and that equals 1 plus 2 tangent square x. Okay, lovely. And one of the things we're going to have is that I like this one because it has us really analyze. It really has us analyze the some of the effects that work with these trig functions. Now, one of the things is this. I want you all to look on the left-hand side. Now, this is important when you work with these functions. Okay. One of the things you do is that you set the right-hand side up, which means that for the most part, it's like a general rule of thumb. This side of the equation, yeah, don't really touch it. Even though it's possible to manipulate it, it's not a good rule of thumb to really now, I want you to look at the trig functions, and I want you to another thing. Get your trig identity sheet. If you don't, please get it out. Please bring out your trig identity sheet. And what I'm going to ask you to do now is look at your trig identity sheet and see if you can find something that resembles what we have up there. Okay, now I'll call somebody randomly to, and if anything, if you get called in, just tell me any similarity that you see or anything that you notice. So look at your trig identity functions on your trig identity sheet. Look at it and see the thrill of selection. This class was 27. Let's see, wait for it for a second. All right, let's go. It's like 14. 14, isn't that, oh, it's you, Reagan? All right, lovely. Okay, now, Reagan, now tell me, did you notice something with your trig identity sheets as, like, what is something you can share with me? Well, let me go ahead and point something out, and this is really important. That's the reason I wanted you to do this, is that currently, I have trig identities up on the board that are to the power of 4. Are any of your trig identities to the power of 4? No, okay, so anytime you see anything that's above, actually, what is the power that you see most of your trig identities? It's the power of 2, squared. Most of them are squared. And that's important because when you sit there and you look at these, if they're above 2, then you're going to factor. If they're below 2, you're probably going to multiply. Okay, that's real important because when you start seeing them, you'll notice that some of them, if they're, the goal is to get them around the power of 2. Because if you get them there, you're actually able to then go about and work with them. Replace them with other things and discover things that will just naturally lend themselves to cancellation. Now, this next piece of math, actually, I would need to go and thank. Hold on a second. I think it's working slow. Whoa, it might have gotten stuck actually. It froze. It didn't like what I was doing. I have faith. This slow. You know what it was? It was part of my. I started publishing the YouTube video from yesterday. It's probably that. Let me just do something. Let me close this out, and then I think it's gonna help. Oh, there we go. Just means too many things are open. Lovely. Listen, we're back online, I think. Let me go to the board and see if I can write something. Now, this next piece of math is actually, I owe the credit to your Algebra 2 teacher. Your Algebra 2 teacher would will present something like this to you, and then he will ask you, is this factorable? Can I factor that? Yes, right, absolutely. Actually, most commonly, you would factor it as x squared minus 4, x squared minus 9. It was perfect squares. And so what about if, oh, man, I thought this thing was good now. Okay, how about if I change this and I ask you to, is this factorable? Yeah, right. Your Algebra 2 teacher said, hey, not that much big difference. You know, you would take it, and instead of putting x minus y, you would now put x squared minus y squared and x squared plus y squared. The only difference coming in that you are now dealing with the difference squares. Lovely. So that's what your Algebra 2 teaches. So when you see them, thank them, because let me see, taught you the skill how to factor this. What your pre-cal teacher is going to show you is you using the same principle, now doing with trig. So now what we're going to do is do the same idea, but now instead of using x, we're going to use secant squared x minus tangent squared x, and its conjugate, secant squared x plus tangent squared x. And the lovely thing about this is that as you write it down, you're gonna realize something. We discover that we now have 4 possibilities of substitutions. There's just not one now. We have 4 choices that you are presented with that you can substitute. This being 1, the 2nd, the 3rd, and the 4th. And this is all good and lovely because we have now choices. As of before, we did not have any. Now you have 4. So I want you to pick one. Pick one out of the 4. Find its identity in your identity sheet. So, and then after that, I'm going to call on somebody randomly to share with me which number they pick. What's its identity? The reason I do this is because when you work on these problems, you're going to be faced with the same type of issue. You're going to be looking at the problem. You did the first step. You got into something you can replace. But now you got options of what you could do, what you can replace it with. So think about some ideas, and then let me call on somebody. Pick one out. There's 4. Okay. Okay. All right, let's see who gets selected on this one. Let's see. All right, 19. Is it you, Spencer? No. Where is it? Oh, it's you, Lizette. Lovely. Okay. Now, which one did you take out of 12? Well, you got 4 choices. So pick one out. You got 1, 2, 3, or 4. Oh, from there. Because remember, secant squared x equals one of the identities. Tangent squared x equals one of the identities. Secant squared x on this side equals one of the identities, and so does tangent. So you have 4 choices. I'll break it down. You can either be secant or tangent. So just tell me one of the, but it could be either of those that you could start with. Secant. Okay, so over here at the beginning. Okay, now to share with me, what does secant square x equal? Yeah, the secant, like where you focus on this one. Now I want you to look at your identity sheet, and on there, you're going to notice that it equals like one of the trig identities. Well, that's for, that's actually true. But I want to get into one of the ones that deals with squares. Because I want to, since this one's square already, I really don't want to go, I find it more beneficial to deal with one of the, it's actually, I want to say it's the second one. On the very top, look at the second one down. Is everybody identified? Is it that one? No? That's 9? Okay. Then it's probably, look at where it says other. It says the one that says some other identities rewritten them. Oh no, it is the second one down. Yeah, look at the very top and look at the second one down. The second trig identity. It's going to say, yeah, y'all see how it says tan theta plus 1 is equal to secant squared x? Okay, so we're gonna substitute that one in, which means at this portion here, I'm going to go ahead and substitute tangent squared x. Was it plus 1? Okay, plus 1 minus tangent squared x, and this is secant squared x plus tan squared x. This is equal to 1 plus 2 tangent squared x. Okay. Now, you naturally, once you write it down, one of the lovely things that's going to start occurring is that you're going to start seeing, you're going to discover things like what you see on the left. Does everybody see how we now can cancel out the tangent squared x and the we have additive inverses in the tangents. We got a tangent square x and a negative tangent squared x. That's lovely because one of the things is that I can now easily remove those from the equation. And this is, so we discovered that these cancel. And we lead with 1, and we just have this secant squared x plus tangent squared x. Now, when you get to this stage, this is when looking at the right-hand side of the equation becomes helpful. Because now I have an option again of either substituting the secant square x or the tangent. But look at the right side. Notice how the right is in tangents. That's going to be your guide. That's what's going to help you in deciding which of these to change. Because look at the right side. You see how the right side of the equation says tangents. So when I look at the left side, the one I should be focusing on changing is going to be the secant, because I want to have it eventually equal to my right. That's what's going to help in guiding you on your selection. So now go ahead and go back and identify your identity for secant square x. It's the same one as the one before, right? So in this case, we're going to go ahead and substitute this. This is really 1 plus tangent squared x plus tangent squared x, and that is equal to 1 plus 2 tangent squared x. Actually, they don't necessarily cancel, they combine. If you notice, that's the thing I love about this, that once you do the replacement, you're going to realize that you're going to have an effective move forward, or you might do replacements and realize that these replacements are moving you backwards or making things harder. Most of the time, or actually, I want to say that when you do replacements, it's going to naturally lead into discovery of things. Now, we were fortunate in picking one. You know how we have 4 choices to begin with? We were lucky in picking one that actually led us to, there's some of those choices up there where we're going to lead us to dead ends. And not necessarily dead ends. You could eventually, but it would have made it really complicated. So the way you got to try it, though, is that once you try it and you realize that it's making it harder than what it should be, you got to go back, simply put. So the lovely thing about this is that now I could combine these 2 terms and end up with my solution at the very end. My left side, so you put the little in conclusion, 1 plus 2 tan of x is equal to 1 plus 2 tangent of x squared x. And that's it. Yes? Oh, what happened with this one? It's an identity. This one? Yeah. This is exactly it. This one right here. Okay, this is an identity property. So when I multiply with this, it just gave this back. And then afterwards, the substitution provided this portion of it there. Now, I guess more of anything, you're probably wondering what happened to this one, right? Oh, this one right here? This is because when you look at your identity sheet, secant squared x equals 1 plus tangent squared x. That's the reason why. That's where that portion came from. All right. Yeah. Yes. All right. So good. So let's go ahead and move on to another one. Let's now work on problem number 10. Let's see, number 10. I think it's 1, is it 1 minus sine theta or 1 plus sine theta? 1 plus sine theta. Okay, and 1 minus sine theta. Yeah, equals the cosine, right? Square theta. Lovely. Now the thing I like about this one, one of the lovely feature that this one has is that it's kind of similar to the one before. If you look at the trig identities on the left-hand side, they're not in, they're all of a power of 1, which means that I need to get it to the power of 2 in most cases. So what I want you to do then is think about what mathematical tool am I going to use in order to bring this to the power of 2. And it's something, again, you would go back and thank your Algebra 2 teacher for showing you. When you look at this, do y'all remember that you could FOIL? You got 2 binomials you could FOIL. That's exactly the skill you're going to use to get closer to our solution. So when we FOIL, then this becomes 1. This is minus sine theta. This is plus sine theta. And our very last is minus sine squared theta. And that's equal to cosine squared theta. So this is lovely. One of the things I discover by, is that I could go ahead and, the middle terms cancel. So I could go ahead and very easily just cross them out. So let me go ahead and quickly do that for you. Let me cancel them out. And this discovery leads us into a simpler form of the equation. 1 minus sine squared theta is equal to cosine squared theta. When you have squares, thank you. All right, let's see, Joey. 3. I think I want you to go right now. All right, good. Now, it's exactly at this point, once you have a square of something, okay, yeah, go ahead and look at your identity sheet. So what I want you to do now is look at your identity sheet. Let me call on somebody randomly to share with me the amount that, the one they would use and what it equals. The real possibly being picked. All right, select 17. Yeah. He's gone. Is it Joey? Joey with 17. Okay, so it lands on the closest one. You do it? Okay. You got a volunteer. All right. So what is yeah, equals cosine squared. It's lovely. Yeah, exactly. That's the and the reason why you're able to do conclusion is that anything that is in your identity sheet, we have proved it already. So it doesn't really require an explanation. It just requires that you understand that this now becomes cosine squared theta, and that equals cosine squared theta.
Yeah, that's what I did.
There's always a lot of these. There's more than one way to do it. Like the one we worked before, not the one before. Yeah, the one before this. There was, yeah, there was 3 different. There was actually 3 different ways to solve that one. 3 or 4. I forget how many, but there's more than one way to do it. So yes, if you came up with an alternate way, you could be absolutely right. Get to the same solution. Okay, excellent. Let's bring in one other. Now I like this next one because um, it's one of those that you take something that you've used a lot, but for some reason when you put trig into it, there's something unique about it. It's number 6. Yeah, number 6. So, and number 6 is secant squared x, yes, plus tangent squared x times secant squared x, and that equals secant to the 4th power x. Lovely. And same thing, the math behind this, you're going to have to thank your Algebra 1 or Algebra 2 teacher for showing you this. But if I brought up x's and y's to represent this situation, it would look like this: x plus yx. And you would sit there and then you would, if I ask you, is that factorable? You would tell me yes. I could factor out an x, correct? And in this case, they have an x in common. And then it's going to become this: x 1 plus y. You probably feel very safe working with this. What we're going to do now is we're actually going to now use trig. Trig is going to be used with the same concept that your Algebra 1, 2 teacher taught you. But instead of factoring in x, I'm going to factor out a secant squared x. Which means that I'm going to place the secant square x on the outside. Just like you see how I place the x on the outside of the parentheses, I'll do the same thing. Secant squared x. And in its place, now this is interesting. I don't know why people don't see this. There's actually a 1 that will be left in its place plus just tangent squared x. That, and then for some reason the people, my students wonder the 1. Same thing, there's a 1 here, there's a 1 there. There is, when you pull out this, you might be wondering where did the 1 come from? Just like this. Yeah, there's a 1 there. Then there's an identity 1. There's an identity 1 here. So when you pull that out, that's what's left in its place. The identity 1 is left. So what we're doing now is that we factor it, and this factoring helps because it kind of simplifies it a little bit more. Now, is it possible to start doing replacements without the factoring? Yes, and you might be able to achieve a solution. But I know that this way is sometimes a bit easier. Now, one of the things I want y'all to do now is look at the, y'all see the secant on the left-hand side? Okay. You probably want to keep that because you see how there's a secant on the right-hand side? So the part you want to focus in is that parentheses, and then identify the right identity for that, and then let me call on you randomly to share it with me. Possibly beats 18. Oh, so it comes to you, Angelica. Okay, great, Angelica. So, what does the 1 plus tangent square x become? Well, it's the second one down on your identity sheet. Like if you look at the very top one, look at the second one. The second one, well, it says tan squared plus 1, right? But you notice the second part of that says equals. So which means that everything you see in this parentheses becomes secant squared x. And this is lovely because I could now discover that, oops, hold on, let me fix this, so forth. The discovery we make is that these squares, when you combine them, is going to make secant, secant to the fourth. Secant to the fourth power, and that's equal to the secant of the fourth power over here. Now, oh, yes, I forgot. Right before, let's put the in conclusion. In conclusion, we can now say that this is guaranteed, and it's proven. It's lovely. Okay, good. Now, there is one last problem I'd like to cover with you because you're going to get to these kind of problems towards the latter part or the later part of the assignment. Like problems 10 on out will cover, you're going to be faced with a different type of challenge. Like let's do number 11, 1 over sine x times cosine x. minus cosine x over sine x. That equals the tangent of x. The unique challenge on this one is that we're dealing with now fractions of trig. Yes. Now I need to, currently this is all simplified for me. I need to kind of start putting things back together. And the only way I could do that is by, when I have fractions, I have to make sure I get a common denominator. So like in this case, you notice how this denominator has sine and cosine? Yes, this one, you discovered that a cosine is necessary if I'm going to combine them. So I solved that problem by multiplying cosine top and bottom. So it's going to mean that I'm going to go ahead and multiply here by cosine x and over here by cosine x. That's going to be the thing that's going to allow me to get a common denominator. So the lovely part about this is that now I could go ahead and write everything down in one common denominator. So I'll have cosine x times sine x. And as the numerator, I'll have 1 minus cosine square x. Because remember, you see how on the numerator part I have two cosines multiplying each other? So I'll end up with cosine square x. I love the fact that now I could go ahead and find an identity property for the numerator. I want you to identify it. I'm going to call somebody randomly. So look at your identity sheet and identify the property for the numerator. I'm going to call somebody randomly. Get called up. Let him pick this up. Okay. Now let's go ahead and select somebody. Real excited. Great. 27. Card.
It's 88 sine.
For the 1 minus cosine squared x?
Yes.
So
Minus cosine.
sine squared x. Right. Okay, lovely. Yes. So what Carver told us right now is that this numerator is actually going to equal sine square x. And so this is going to be over cosine x times sine x. And this is going to be equal to tangent x. Mm-hmm. Yes. Yes. Yeah, I have them right here. I'll get them to you right now in a second. Okay. Yeah, the next step that we're going to do. Okay. Let me go ahead and change this. Okay, and this is one of the things I'm going to do. I'm going to go ahead and now separate this. This is going to be sine x times sine x. And the reason I'm separating is because some people are seeing it already. You're like, you can cancel out one of the sine x's. And that's absolutely what we're going to do. So we're going to cancel out the sine x and the sine x. And what we're going to have is that this, remember tangent, when you look at your identity property, equals sine x over cosine x. So like in this case, we'll have tangent x is equal to tangent x because of this part of it. Okay, lovely. All right, let's go ahead and what I want you to do now is go back to column 2 and then start working with that. Remember what I said at the beginning of the thing. When you, especially with problems 2, 3, and then problems 2 and 3, you want to make sure that you want to make sure that you see sine and cosine.